In this screencast, we will talk about properties. Properties are like rules. Rules are going to be used in all situations. There are three different properties that we're going to talk about. The first one is called the commutative property. There's an addition commutative property and a multiplication property. And we're going to talk about associative properties, addition and multiplication. And then the last one is distributive property. Let me start by writing the properties and discussing them a little bit, and then we'll get in more detail. The commutative property states that if you take any two numbers or letters, A plus B, that will always be equal to B plus A. Now, it might be confusing right now about why we need to know this, but you'll see it as we get into algebra that we need to move things around. So if we have an A plus B, we can make it B plus A. So if I put 3 plus 5, that equals 5 plus 3. So that's the distributive property for addition. It also works for multiplication. A times B equals B times A. So again, if we put 2 times 5, that's 10. And switch the order, 5 times 2, that's also 10. So those are the commutative properties. Associative property. A plus B plus C. This is where we have three numbers or letters. So A plus B plus C is equal to A plus parentheses B plus C. What this is really doing is it's just changing which numbers we add first. So in this case, we would add A plus B first, get a sum, and then add C. In this case, we would add B plus C first, get a sum, and then add it to A. So these parentheses just change the order in which we add the numbers. And it works the same for multiplication. A times B times C equals A times parentheses B times C. Okay. There's two different distributive properties. A times B plus C equals A times B plus A times C. Okay. The other direction, I'll just write it, is AB plus AC. And we changed to taking the A out because it's in both of them. A, and then take it out of both, the B plus the C. This was a little more confusing to see in this form, but as we look at it later on, it should be a little bit more clear. Alright, so what I want to do is I want to get into some examples, a little more clarity on what they mean and how we're going to use them, and an example on how we're going to use all of them possible together. Alright, so we have the commutative property of addition. Again, it's A plus B equals B plus A. So again, if I put numbers in, 6 plus 2 equals 2 plus 6. True statement. If I put a letter in, A plus 4 equals 4 plus A. Again, that might be confusing, but just see that you can just switch the order of the number. It doesn't change the value. If I said A was 6, 6 plus 4 is 10, 4 plus 6 is 10, so it doesn't change. Multiplication. A times B equals B times A. I'll get some numbers. 3 times 2 is the same as 2 times 3, which is 6 and 6. 5 times B times 5. Again, if I plug in a 1 for B, 5 times 1 is 5, 1 times 5 is 5. So commutative property. You will at some point have to memorize which properties go with what name. Commutative. 2 M's in commutative probably isn't going to help you because there's 2 to S is an associative, but try to think of a way to remember that. So commutative is where there's two numbers or letters and you switch their order. So that's commutative. The second one is associative property. In the associative property, we have more than two, and we're going to switch their order. We start by writing it again. A plus A plus B in parentheses, and adding C after is the same as adding the second and third numbers first. So let's plug the values in. 6 plus 3 plus 2 is the same as, hopefully, 6 plus 3 plus 2. Again, you can notice I didn't change letters, so I put 6 in the A spot, 3 for B, and 2 for C. So it's this one is 9 plus 2, which is 11. And this one is 6 plus 5, which is 11. So there's an example. Another example might be, I don't want to really show you the algebra because that might be confusing for now, but you'll see later on why we can do it. Multiplication. A times B times C is the same as A times B times C. Example for that one. 6 times 3 times 4 equals 6 times 3 times 4. So we got 18 times 4, which is 40 plus 32, that's 72. And this is 6 times 12, which is also 17. So this is the associative property. 3 numbers or variables in which we want to, instead of multiplying or adding a certain two, we want to change it. So that's the associative property. Third and final property is the distributive property. In the distributive property, we're going to take A times B plus C is equal to AB plus AC. Or if we work backwards, AB plus AC is A times B plus C. It's probably the hardest one to understand, so I'll take a little more time on this. But for an example, if I put 5 times 3 plus 2, okay, if we just solve for this, it would be 5 times 5, so this would be 25. And that's what the value is going to be. But what we can do is we can just do 5 times 3 plus 5 times 2. So this is 5 times 5 if we were to solve it. So we should get a value of 25. Here it's 5 times 3, which is 15, and it's 5 times 2, which is 10. Now, a story problem might be we have five kids, and we want to give each kid 3 pencils and 2 pens. So we go, you know, how many writing utensils or would they have after we gave, or we could do 5 times 5, of course, or we could go 5 times 3 plus 2, 5 times 3 for pencils, plus 5 times 2 for pens, so 25. There's our example. Or we can go the opposite direction. This one, I tried to make too confusing, but let me just put a number like 20 plus 15. What we need to do is we need to find a factor, and we want to find the greatest common factor of 20 and 15. So we're going to use some of that skill we've used prior. Greatest common factor. So again, one method would be to list them. 1 times 20, 2 times 10, 4 times 5, 15 is 1 times 15, 3 times 5. Greatest common factor is 5. So that's the number that we're going to pull out for A here. So that equals 5 times. So how do we get to 20? Well, this can be written, if 5 is our A, we can go 5 times 4 and 5 times 3. Now I took the whole number 20, turned it into a multiplication of our greatest common factor 5, which is A, times 4 to get to 20, and then C would be 3 because it's 5 times 3. But what you can hopefully notice is that there's the number 5 is in both of them, and that's our greatest common factor. So now we have 5 times. What is B? B was 4. 5 times 4 plus 5 times 3 equals that. So we can work backwards as well. So those are our 3 properties, and I would like to show you one more thing. That might be an example. So now let's apply our properties to a couple of problems. We have 3 plus 2a plus 5 plus 3a. Now one thing we're going to learn later on is we can combine like terms. Like terms are numbers that have the same variable raised to the same power. In this case we have a and a. So these two can be combined because there's 3a and 2a, and those can of course be combined. So the first thing we'll do is we are going to do this. 3 plus parentheses 2a plus 5 plus 3a. And that is the commutative associative property. Because we went from these two being first to those two. And the second thing we'll do is we'll use our commutative property, and that just takes these two numbers and switches them. So our commutative property, we then can, by rule, switch these numbers. And then now we can add, I think this becomes the associative again. I'm going to go back to 3 plus 5 plus 2a plus 3a. Now we have our problem. Our answer, 3 plus 5 is 8, plus 2a plus 3a is 5a. So that's how we can use our properties. So we can, you really can in your head, just if they have the same, 2a plus 3a is 5a, and 3 plus 5 is 8. But technically, how do we do it? We use properties. We switch the numbers, we move them around, and we end up getting them next to each other. Last one would be 2 times this. Well, we need to use the distributive property. It changes to 2 times 3a, which is 6a, plus 2 times b, which is 2b, plus our other 2b plus 4a. So now quickly we can use our properties. That was distributive. We can do this first, and now we can move 6a plus 2b plus 4a plus 2b. So I just moved these two. Now I need to move these two, which is 6a plus 4a plus 2b plus 2b. And now I can add 6a plus 4a, because I have them next to each other, plus 2b plus 2b, and they can be combined because they have b, and it ends up being 6a plus 4a, 10a, plus 2b plus 2b is 4b. Okay, so we're going to use these properties, and right now it might be a little confusing, but when we get to the end, hopefully we'll be able to better understand.